Hey, welcome back guys. In this episode I'm going to turn Berocca's single coil neck pickup into a humbucker. Over the years I've wound tons of pickups. I've never really been a full-time pickup winding guy, but one thing I have never done is a 5-string side-by-side split coil pickup for a jazz bass. I've wound quite a few 4-strings that way, and it's pretty straightforward because the two coils are the same size. But in a 5-string, of course, one coil is for 2 strings, the other is for 3, and the coils will be different sizes. And they'll also have a different amount of magnets in them. And the size and also the iron content brought by the magnets within the coils is a big factor in the overall inductance of the coil. And the inductance plays a big role in the output and also the tone of the pickup. I've got a few ideas in mind about how to match the inductance across the two coils, but I'll be honest, I'm really not sure which strategies or single strategy is going to work. So come with me on a journey of discovery. So here are my 2 bobbins. I just cut the existing one in half and flipped the short side of it. I didn't actually take the magnets out. I simply pressed them further in so that the tops will be flush with the top of the pickup cover. Instead of eyelets, I've just gone with a little piece of this copper-clad PCB material, and I've taken a score down the middle to separate it into 2 separate lands or pads. The holes are for the magnet wire, and then I can just solder the pickup leads directly to the copper. Okay, so here are our 2 coils. I wound the short one first and stopped when it was just sort of bulging past the cut. I got 4,000 turns on that one, so I went ahead and wound the other coil with 4,000 turns as well. This one has a DC resistance of about 1.8 k ohms, and the big bobbin has 2.5 k ohms. And with my cheap and cheerful inductance meter, the short bobbin has about 1/3 of a Henry, and the long bobbin has about 1/2 a Henry. There is a better way to measure inductance, and I'm going to do that in a sec. But to give you an idea, the coils on my 73P bass have, I think from memory, about 5.5 k ohms of DC resistance and about 3 or 3.5 Henrys each of inductance. So there's clearly a big difference. There's a lot more wire on those bobbins. They're much wider than these. I'm guessing there's probably 10,000 turns on each of those coils. So all pickup coils have capacitance. I guess it comes from wrapping wire on wire on wire, and the insulation on the wire sort of starts acting like the dielectric in a capacitor. And it's the capacitance of the coil in conjunction with the inductance that actually creates the resonant peak of the coil, the resonant frequency of the coil. And that more or less gives us the treble response of the pickup, or kind of the full treble potential of the pickup, I guess is probably a better way to think of it. The trouble with one of these is that you just can't use a capacitance meter to measure that capacitance. So the way to do it is to add in parallel with the coil a known capacitance and then measure its resonant frequency. And once you've done that, then you can solve for inductance. If you're lazy like me, you can just use an online calculator. It's a lot easier. And once you've done that for 2 or 3 known capacitors, then you can get a really good idea of what the actual inductance of the coil is, and you can go back without the capacitor and use the original resonant frequency of the coil that was measured with the sort of XY function on my USB scope, and then solve for capacitance, and that'll give you the stray capacitance, or the parasitic capacitance as it's also called. Oddly enough, these 2 coils have much the same stray capacitance. I think they both worked out to be within a few percent of 100 picofarads. I'm actually not really sure why two coils that are so different in size have the same capacitance. I'm guessing it's something to do with just hand winding and hand tensioning, and the sort of inconsistencies of all that. To be honest, I'm not really worried about slight differences in tone between the two coils, and that's because these are going to have a very high frequency response anyway, because they're so underwound compared to traditional Fender coils. And to be honest, you know, in that top octave of human hearing between 10 and 20 kilohertz, a plucked bass string, even a brand new one, doesn't really create a lot of action. To be honest, I'm more worried about the difference in output of the two coils. I really want the two strings to have the same output as the other three, or vice versa. I guess I could add a couple of little neo magnets or something onto the bottom of this little coil. That does increase the sensitivity of the pickup and will actually boost the output, but you have to be careful with that, because if you add too much magnetism, especially in a neck pickup, you start getting wolf tones, dead spots, and other problems. I won't bore you with the details, but you can Google on string pull or stratitis for a bit more info. I do have a few ideas though about how to redesign this bobbin and rewind it and get some more inductance and hopefully match the output of the big coil. But I'll come back to that. I think what I'll do right now is just put them in the bass as they are, and we'll see if we can actually hear some of these things that I've been measuring and talking about. Well, it certainly hum cancels, not perfectly, as you'd expect with two different sized coils, but it's a hell of a lot better than the single coil was, that's for sure. The tone of the pickup is quite even through the treble, frankly a little bit bland, but that's also to be expected, I guess, when the resonant peak is just so high, up at I think 15 kilohertz, I think it was. Again, that's okay. Planning to create my own resonant peak with either capacitive loading or maybe even an active low pass filter, sort of down the track in the process when I go ahead and design the active blend control. With an active blend control, you can filter one pickup without affecting the other, so that's okay. The difference in output from one coil to the other, it is noticeable. It's kind of hard to demonstrate. It's kind of hard to demonstrate on camera, but it is noticeable, and I think it would be really obvious, especially with my big stage rig. Overall, I think the output's a little bit low. It's really no match for the Stingray pickup that's in here, although I am planning to switch that from series to parallel, which will drop its output by 5 or 6 dB, but it's still quite low. Again, I could add a little bit of gain to that side of the blend control, but I was originally going to just work on the short coil, but I think I'm going to work on both bobbins. So here are my two coils. The long coil, the 3-string coil, I've actually cut down the middle after I pushed the magnets out. Then I removed some of the excess plastic, and then I've re-glued it just using the full height of the magnets. So this, I would think, is about 3 millimeters taller than it was, so I'll get a bit more wire on that, which is a good thing. And here's the 2-string coil, and I've done a number of mods to this. I've added a magnet to the outside. That'll give me a bigger coil, again, meaning I can get a bit more wire on it. And I've put a magnet in between the two existing magnets. Adding those magnets inside the coil just puts more iron in there, and that should boost the inductance as well. I've also replaced the 4 main magnets with some that I found in my junk box, and they're also a bit taller. So when I re-glued it, I'm left with a coil. It's a good sort of 2 or 3 millimeters taller than the other bobbin. I think I'll do the same thing. I think I'll just wind as much as I can onto the small coil, and then just put the same number of turns, or maybe slightly less actually, maybe 10% less on the long coil, and I think I'll have a pretty good match. But before I do that, I want to show you something that I found in my junk box. So this is one half of a very cheap and cheerful P-base pickup. It would have originally had a ceramic magnet on the bottom, but that's gone now. So these pole pieces in here are just steel rods. And the nice thing about these plastic bobbins, a bit like the one I've been working on, is you can push these pole pieces through without damaging the coil. They can be quite tight. But I'm going to push those through, and I want to show you something. So I've got the coil with all the slugs taken out, and it's hooked up to my LC meter, and it's reading about 1.2 Henrys. If I put one of the slugs back in, it jumps up to 1.5 Henrys, and then as I add a second, we're 1.8, and that's 2, and then with all 4 steel pins inside the coil, we've almost doubled the inductance. So now all 4 pins are sort of half in, and the inductance is 1.8 Henrys. And if I take 2 of them out completely, and you might remember that with 2 of them all the way in, it's about the same. So it really has to do with the iron that's actually inside the coil. Iron around the coil does affect the inductance, but inside the coil has a much greater effect. Alnico magnets have an iron content, I think, around about the 50% mark, which is much lower than these steel rods. So I'm not really expecting the 2 Alnicos I've added to the 2-string coil to massively change the inductance, but they'll certainly help. So here are my 2 coils. Started on the little guy and wound it until it was just kind of bulging out past where the 2 coils are going to meet inside the cover. And I managed to get 6,500 turns on that one this time, up from 4,000 I think. And that's, I guess, due to the extra height and all the plastic that's been removed from around the magnets. The DC resistance of that is about 3.2 k ohms, and that's really just an indication of the length of wire that's on each coil. This guy, I just kind of guessed and wound it 10% under, so this has got 5,800 turns, and it still has a tiny bit more DC resistance, so it has a little bit more wire on it at I think 3.5 k ohms, but as per my little inductance meter there, they're actually within about 10% of each other. In fact, this guy has a touch less inductance than this one. So I think it's time to do some proper testing with the USB scope, and then to put it back in the base and have a listen. Well, it's a few days later, and I'm happy with the pickup at last. I did end up rewinding it several times, and I now know in hindsight that my very first wind after rebuilding the bobbins was actually not a bad compromise, and I probably could have left it the way it was. But there was something that was sort of nagging on me, and that was that the coil that I expected to have more capacitance actually had quite a bit less capacitance than the other coil. So I rewound them. I guess if you've seen my other videos or you've met me in person, you know I have an insatiable curiosity for this sort of stuff. And after I rewound them, I found with testing that they had an even greater difference in capacitance, but now they'd swapped coils. So now it was the other coil that had more capacitance. So I knew there was something going on, and I knew I had to maybe find a way of improving the consistency of the coils I was winding. There's nothing really wrong with tensioning and winding by hand. It's certainly the way they did it back, I think, in the 50s and 60s, and there's tons of guys that still do it, and I'll continue to do it for certain projects. But for this, where I was trying to say wind one coil and then wind the other coil to match it, or start low and then build it up and everything, I really needed a way of having much more consistent tension in the coil. So with that in mind, I built this guy. It's more or less modelled, or I guess a complete rip-off of the ones that StewMax sell. I made it one afternoon just out of bits and pieces of junk and stuff that I had lying around. But essentially it's got an adjustable belt-lined clamp that allows me to tension the wire and have a consistent tension, not just through one coil, but when I move on to another coil I can keep it set up and then wind that coil to roughly the same tension. It's certainly not a surgical device, let's face it, it's quite a rudimentary sort of way of doing it, but it did really help me understand what was going on with the coils. And yes, capacitance was the big factor here. One thing I did do, I actually grabbed a few sort of junk coils, junk jazz-based pickups or whatever from my box, and rewind them with the same number of turns, but cranking the tension across, say, 3 winds and testing them each time. And something I found was that with more tension on the coil, you use less wire. And I guess that's fairly understandable because you're just wrapping it more tightly. So that reduces the DC resistance, which again is an indication of the length of coil itself or the length of wire you've used. And that does drop the inductance slightly, but what it actually does is it boosts the capacitance of the coil disproportionately to that drop in inductance. So that's when it kind of dawned on me that when you go back and look at the equation or the formula, I guess, for the resonance, and you're solving for frequency, you notice that L and C are together in the formulation. And what this means is that if you have one coil, say, with 2 units of inductance and 3 units of capacitance, it has the same resonant frequency as another coil with, say, 3 units of inductance and 2 of capacitance, or even 1 unit of inductance and 6 units of capacitance. Because now I realized what I had to do was actually try and match the product of inductance and capacitance between the 2 coils. There is quite a bit more to it, of course, and I think the next thing I'm going to try and get my head around is how inductance and resistance work together and how that affects the height of the resonant peak or the Q factor of the coil. But for now I'm happy. The pickup has hit the brief. It's dead silent. If I crank my amp, there's really no hum at all. It has a nice even response. And a nice sort of even treble response as well. For what it's worth, I did end up winding the short coil a little bit tighter, and it's got 6,000 turns on it, and the long coil's got 4,500 turns on it. So both coils actually have the same DC resistance, or very close, at 3 k ohms. And they also have a very similar resonant frequency. The short coil is 12 kilohertz and the long coil is 13 kilohertz. And that's because that product between inductance and capacitance is very similar. The long coil actually has slightly less inductance but more capacitance, and the short coil vice versa. Do let me know in the comments if you think I'm on the right track here, or if I've sort of missed the mark. Especially I'd love to hear from you if you are, say, an engineer working in coil manufacturer or whatever. It'd be really interesting to read your comments. And as I mentioned, if you'd like to see more info on this, let me know, because I could probably put together a little video on it. In the next video I'll be making an active blend control, and I'll be playing around with some more of this and messing around with the treble response of both pickups actually. So I hope you've enjoyed this video, and I hope to see you in the next one. I'll see you then.